Hi, everyone. Today we're going to continue looking at life and the possibility that it may or may not be elsewhere, somewhere besides Earth. If you need to get hold of me, my email address is here on the screen, rcrawford@jcpsmail.org. Let's dive right in. So I think anytime we talk about life, we really need to start thinking about what do we mean by that? So, what type of life are we talking about? Are we talking about primitive life? So, are we talking about simple single-celled organisms, things that you would need a microscope to see, things like bacteria, microbes, single cells? Are we talking about complex life? And if we define complex life, maybe we're talking about multicellular organisms that have organ systems, and each organ system has its own job. Oftentimes, I find, though, that we're talking about intelligent life. And when we think about intelligent life, that can be difficult to define. Are we talking about life that is able to develop and use technology? That describes humans pretty well. Are we talking about life that has complex means of communication? Well, that can describe humans, but there are other organisms on our planet, in fact, that have arguably more complex communications means than we do. Are we talking about an organism that can survive, or life that can survive for a very long time without destroying the environment? So, when we talk about intelligent life, even that can be a bit of a difficult thing to define. So, life elsewhere. Mathematically, and I think this came through in the video you watched yesterday, there are lots of opportunities for life to exist elsewhere, even within our Milky Way. So if we look at our Milky Way has about 400 billion stars. And of those stars, we have about 20 billion of those stars that are somewhat sun-like. So 20 billion possible stars that could provide a stable environment. But then when we go further and we look, we find that we have about 4 billion Earth-like planets in a habitable zone. Now, when we say Earth-like, that may not include all of those things that we've been talking about that might make Earth rare. And I mean the rare Earth hypothesis. We're talking about planets in a habitable zone. 4 billion, though. So if we were to take somehow those 4 billion planets that would be around the right size star in the habitable zone, and we were just to assume that 0.1% of those planets are going to develop life, that would still give us 1 million planets in the Milky Way alone. Now, realize this assumption means that 99.9% of Earth-like planets in a habitable zone around the right size star, on those planets, life wouldn't develop. So that's a very low success rate, but we still end up with 1 million possible planets with life, Earth-like planets with possible life. So mathematically, plenty of opportunities for life to exist. And so people have been working with this idea for years. There is an equation called the Drake equation that is used to really uses math to estimate the number of advanced civilizations. And so the Drake equation tries to get to intelligent life. And we're going to come back to that first off. Because when we talk about life and discovering it, um, oftentimes we're more we're more interested in discovering life that would be more like us, and I think we would define ourselves as intelligent life or an intelligent civilization. Okay, so really yesterday we looked a little bit at the Fermi paradox. The Fermi paradox, to make it as simple as I can, basically says this: where are the aliens? So if mathematically there are so many places just in our galaxy alone that we should see that their life could have developed, then why do we not see that life? Why are we not contacted by intelligent life? Well, even though life could have developed in lots of places in our galaxy, it turns out that when we use the Drake equation, that 1 million possible places where life could have developed turns out to be a significantly smaller number. Because really, we're not just talking about life, we're talking about intelligent life. We're talking about intelligent life that is able to have communications that use really radio signals, that is going to have a long lifetime. And so that number turns out to be quite a bit smaller when we talk about intelligent life just versus life. I've seen estimates, because remember these are estimates, of anywhere from 1 to 23. So when we look at the Fermi paradox, even if it's just one, well, that would mean honestly that the rare Earth people are really in the right place. But if it's 23, then that's 23 other advanced civilizations with intelligent life, and that's considerably more. So if there are 23, then where are they? So there are several solutions to the Fermi paradox. Where are the aliens? Of course, we've decided that one of those would be, well, honestly, the solution is simple. There are no other civilizations out there. We are alone in the universe. Another possible solution, though, is that um, maybe we're just late to the party. Maybe we developed intelligence after life from elsewhere had already visited Earth. Now, that sounds really crazy, but remember, we're just trying to think a little bit outside the box. The middle of nowhere. So, this is a hypothesis or a solution to the Fermi paradox that would say, you know what, the galaxy has mostly already been colonized, but Earth is just really in a desolate corner of our galaxy, and nobody's interested in visiting this place because it's not very dense. So let's look at three more possibilities, three more solutions to that Fermi paradox of where are the aliens. Well, there's also the possibility that we are the first. And so it is possible that life is complex life and our intelligent life is in the process of developing elsewhere, but it happened to develop here on Earth first. Um, so another possible solution would be there have been other advanced civilizations, and maybe they developed about the same time as us. And so, like us, they're just now really their technology is just allowing them to explore some of these bigger questions. Um, Another possible solution, and this is one that is often pointed to by scientists, is the idea that the distances between these different Earth-like planets where life could possibly have developed are just too far. So we are just too far apart to even begin to imagine communicating with them or having or being able to see them. And so those are three possibilities that are six possibilities that might answer that Fermi paradox. So those are some possible solutions. We're going to look at a couple more of those solutions later on, but that's going to do it for today.